Welcome to Tomorrow Unveiled, the show where we cut through the noise to bring you the most important, surprising, and often mind-blowing insights from the forefront of technology. Today, we're tackling a phrase that has long captivated our imagination, the rise of the machines. But forget the sci-fi movies for a moment. We're diving into the rapid, real-world acceleration of humanoid robotics happening right now. Our mission today is to uncover the most significant advancements transforming these human-shaped robots from laboratory concepts into incredibly practical tools, drawing on the cross-corroborated insights from the latest research.
It's true. We've definitely hit a critical inflection point in this industry. The market is clearly shifting from simply demonstrating that a humanoid robot can exist to actually proving what it can do. The data we've been reviewing, collected by our research team, it reveals staggering market potential. Some forecasts predicting billions, maybe even trillions, in market value by 2035. It really spans industrial, service, and even domestic applications. It's no longer a question of if, really, but when and how widely.
Okay, let's unpack this then. It's interesting that these robots are shaped like us, isn't it? I mean, our world is designed for humans, right? For human hands, human heights, human movement. That foundational fact makes human-shaped robots uniquely adaptable. They can sort of step into environments and use tools that are already everywhere. So let's dig into the strategic shift we've seen. For years, the holy grail was just getting these robots to walk reliably without, falling over, stable bipedal locomotion. And while that's still a monumental feat of engineering, the focus seems to have fundamentally shifted. It's no longer just about how they get there, but about their utility once they arrive. What's the real pivot here?
Yeah, exactly. The emphasis is now squarely on manipulation, interaction, and seamless integration into economically valuable workflows. The goal isn't just a robot that can walk. It's a robot that can work. Think about it. If you want a robot to operate in a factory, a hospital, or even your home, it needs to be able to open the same door.
Just navigate the same stairs.
Right, and pick up the same tools that humans do. That's why the human form factor is so crucial. These advancements mean we can truly imagine robots integrating into environments already built for human interaction.
Okay, here's where it gets really interesting, I think. Let's talk about the foundational technological breakthroughs enabling all of this. Maybe starting with a crucial hardware innovation. What's giving these robots a real sense of touch?
Right. We're seeing a pretty groundbreaking development in electronic skin, or e-skin. Imagine a low-cost, flexible, gelatin-based hydrogel. Now, this material is packed with unprecedented density of sensors. It allows a robot to feel touch, pressure, and even temperature across its entire surface. And importantly, this isn't just about simple pressure like on or off. It's a nuanced human-like sensation, capable of distinguishing multiple types of stimuli.
So if I'm understanding this, this isn't just a basic sensor saying contact, it's truly multimodal, kind of like our own skin.
Exactly. It directly addresses what's often called the last-inch problem in robotics. That's the challenge of fine-grained, nuanced interaction with objects and environments. Humans do this effortlessly, but robots have historically struggled. This e-skin provides high-resolution, multimodal feedback across the entire surface of, say, a robotic hand, much like the human somatosensory system. So a humanoid equipped with this could not only grasp a cup but also feel its temperature, detect if it's slipping.
Know how it's holding it.
Precisely. And know precisely which fingers are making contact. And crucially, it could also detect an unexpected touch from a human coworker and react instantly, safely. This level of sensory fidelity is, well, it's a fundamental prerequisite for general-purpose manipulation and safer operation near humans.
So we've got the hardware for a human-like touch. That's huge. But what's going on in the robot's mind, so to speak? How are these humanoids actually thinking and interacting?
Ah, yes. That's where the cognitive leap comes in. And it's heavily driven by advancements in AI. The brain of these humanoids is getting a massive upgrade in a few key areas, according to the research. First, for planning and foresight, we're seeing something called humanoid world models. Essentially, these allow robots to imagine the consequences of their actions. That's absolutely crucial for long horizon planning in complex, unpredictable environments. It's like giving the robot foresight, enabling it to simulate actions internally before committing to them in the physical world.
Okay, so they can think ahead. What else?
Then there's standing tall. This is a robust, real-time fall prediction system. It anticipates falls with enough lead time, we're talking over 0.2 seconds, to trigger a recovery maneuver, like shifting weight or taking a quick step. In simulations, based on the papers our team analyzed, it's achieved an impressive 97% success rate in stabilizing robots from otherwise unrecoverable falls.
Wow. 97%.
Yeah, and importantly, with near zero false positives. This isn't just academic, it's a fundamental safety feature. As critical to a mobile robot as brakes are to a car, really. Essential for any real-world deployment.
Makes sense. You can't have them falling over constantly.
Definitely not. And for interaction, we're seeing progress with hierarchical intention-aware motion. This allows robots to understand human social intentions. They use vision language models, that's AI, that understands both what it sees and what humans communicate in language. And then based on that understanding, they generate socially appropriate motions.
So it could tell if I'm waving hello versus waving it away.
Exactly. Or understand if you're questioning it or warning it, and then respond with natural, nonverbal cues. This is really vital for effective human-robot collaboration and, frankly, user acceptance. People need to feel comfortable.
Right. Beyond these sort of core academic breakthroughs, we're also seeing specialized AI models making a splash. Can you tell us about 1X Technologies' Redwood AI?
Yes, Redwood AI is a good example. It's a vision language transformer. So, similar to the powerful AI architectures used in large language models like ChatGPT, but specifically tailored for humanoid household tasks. Our research indicates it's capable of end-to-end mobile manipulation in unstructured home environments. Meaning it can handle the whole process, seeing, deciding, acting. It can do everything from doing laundry and making coffee to tidying up a room. What's particularly impressive and noted in the research is that it runs entirely on board the robot. No constant reliance on cloud computing.
That is impressive. Shows incredible efficiency for that kind of AI operating in just, everyday setting.
Oh, it really does.
So what does this all mean when you pull these distinct advancements together? The eSkin, the world models, the interaction AI, these specific task models. How are these sophisticated capabilities being integrated and scaled for real-world use?
Well, this leads directly to the emergence of comprehensive end-to-end development platforms. You could call it the AI factory ecosystem. NVIDIA's Isaac platform is probably the most prominent example right now. They provide a full-stack cloud-to-robot solution. They recently introduced Isaac GR00T N1.5. That's their updated foundation AI model for humanoid reasoning and skills. Think of it as a general brain they can build on. But perhaps even more impactful, based on our team's analysis, is GR00T Dreams. This is their synthetic data generation tool. This system can take just a single image as input and generate vast quantities of synthetic motion data. Basically, it shows a robot performing new tasks in new environments, all generated virtually.
Okay, hold on. So instead of filming a robot doing something thousands of times, you just give it a picture and the AI dreams up the training data. That sounds like a massive shortcut, right? Cutting down the time it takes to train robots?
Absolutely. It's a huge accelerator. What used to take maybe 3 months using traditional manual data collection, filming robots over and over, can now potentially be completed in just 36 hours using synthetic data.
36 hours.
That's the claim. It drastically cuts training time and cost. And it means the competitive edge for robotics firms is shifting. While hardware is still absolutely essential, the real advantage might belong to the companies with the most efficient software pipeline, the AI factory, that can generate, train, and deploy intelligent policies at an unprecedented rate.
Okay, this is moving fast. It's one thing to talk about labs and models and AI factories, but what are these machines actually doing out there in the wild? Let's move from the theoretical to the tangible. What are the commercial deployments looking like, and how are they scaling up?
Yeah, good question. We're seeing real, concrete progress in industrial applications now. Figure AI, for example, has that pilot program with BMW. Their Figure O2 Humanoid recently worked multiple consecutive shifts, reports say up to 20 hours on an assembly line.
Doing what exactly?
It was picking and inserting sheet metal parts with apparently incredible precision. And the key data point is that it achieved a 400% speed increase and a 7-fold boost in success rate on that specific task after iterative improvements. So this really showcases humanoids handling tedious, repetitive assembly tasks for extended durations, which is a core industrial need.
20 hours straight is significant.
It is. Then there's Agility Robotics. They've actually achieved what looks like the industry's first formal commercial deployment of humanoids. Their digit robots are working with GXO logistics, handling totes, moving boxes around, assisting with order fulfillment in a warehouse setting. And we're also seeing Mercedes-Benz trialing Apptronic's Apollo Humanoid for tasks that address labor shortages and ergonomic challenges in their factories, things that are tough or injury-prone for humans.
So these are concrete examples of humanoids moving beyond just pilots into actual, production environments.
That's the trajectory, yes.
Okay, so it's not just factories, right? Are we seeing them pop up in service roles or delivery?
Absolutely. The applications are broadening. RigTech Robotics, Edem Robot, it's sort of semi-humanoid torso and arms, is a great example. It has successfully served over 16,000 drinks in a commercial setting in Las Vegas, like a robotic bartender.
16,000 drinks. Okay.
And Amazon is making a serious strategic push into last-mile delivery. This is a big one to watch. They're developing core AI software specifically for humanoid robots and testing them in what they call a humanoid park. Their proposed model seems to be a hybrid one. A human drives a van, and then the humanoid exits the vehicle at each stop to carry the package to the customer's doorstep.
Interesting, taking the robot right to the front door.
Right. Tackling that final, often inefficient step.
This all sounds like massive investments, though, mostly from tech giants and big auto companies.
Yeah.
Are these advancements only for the really big players, or is there a way for smaller teams, researchers, universities to get involved? Is access to this kind of technology being democratized at all?
That's another really fascinating development, actually. And the answer is yes, increasingly. Hugging Face, which is a leading AI community platform, recently introduced open-source humanoids. This is a big announcement. There's Hope JR, which is a full-size humanoid priced at around $3,000. And then there's a desktop-sized one, Reachy Mini, which goes for about $250, $300.
Wait, hang on. $3,000 for a full-size humanoid platform? That's genuinely a game changer for accessibility.
It really is. I mean, compare that to the hundreds of thousands or millions these industrial prototypes cost. It drastically lowers the barrier to entry for working with physical humanoid robotics. Now, this isn't about competing directly with, say, Figure AI's performance metrics on day one.
Sure.
But it's about fostering a global community of developers, researchers, students. It accelerates innovation from the ground up, complementing those top-down industrial pushes we just discussed. Universities, startups, even individual hobbyists can now actually afford to work with this kind of hardware, creating a fertile ground for new ideas, new algorithms, new applications.
That could really speed things up across the board. All right, if you're finding this deep dive insightful, please take a moment to like this video if you're on YouTube, subscribe to Tomorrow Unveiled, and definitely turn on notifications so you never miss an update on the future. And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review. It genuinely helps us reach new listeners who are curious about this stuff. Okay, so we've talked about where humanoids are working and the tech enabling them. But this brings up a bigger question, I think. Why invest so much in the humanoid form factor specifically when other robot forms exist? We've got wheeled delivery bots like Coco, industrial arms, rovers, those quadrupedal robots like Boston Dynamics Spot. What's the compelling reason for the human shape, given its complexity?
That's a really crucial distinction to make. And you're right, those specialized non-humanoid robots are often excellent at specific tasks. A wheeled delivery bot is highly optimized for smooth sidewalks. A dedicated industrial arm from someone like Sunrise Robotics is designed perfectly for repetitive factory tasks. But humanoids offer something different: unparalleled generality. What's fascinating here, and it circles back to your earlier point, is that the world is already designed for the human form. Our buildings, our tools, our workflows.
Right, the infrastructure is already there.
Exactly. This means humanoids have the ultimate built-in advantage in adaptability. They can potentially perform any human task, or at least a very wide range of them, in the same spaces we use, using the same tools we use. You know, a snake-like robot might be great for inspecting pipes, or a wheeled bot for smooth factory floors, but they can't handle stairs easily, or open most doors, or pick up a tool that someone dropped. The long-term transformative potential of a truly general-purpose humanoid, that's what justifies the immense complexity and cost involved in developing them. It's a platform that, potentially, with different software policies loaded onto it, could work in a warehouse one day, a retail store the next, and maybe a delivery route the day after. That's the vision.
That really clarifies the strategic bet being made here, this generality. Okay, so this inevitably raises an important question. What are the broader applications and implications for society and, our future workforce as these humanoids become more capable and more common?
Well, historically, there have been some key challenges that have impeded widespread adoption. But the breakthroughs we've discussed are directly tackling them, based on our research team's analysis. First, high costs. We mentioned that. But the new electronic skin, being gelatin-based and scalable, and the open-source models like Hope JR are pushing down component and development costs significantly. Mercedes-Benz, for instance, is reportedly targeting a price point of tens of thousands per unit for wider deployment. That's still a lot, but it's a huge drop from where things were.
Okay, so cost is coming down. What else?
Then there are the intelligence gaps. The new AI models we talked about, humanoid world models for planning, hierarchical intention-aware motion for social interaction, they're rapidly closing these gaps, making the robots smarter and more adaptable. And finally, data shortages. This has always been a major hurdle in training complex AI. But synthetic data generation, like NVIDIA's GR0T Dreams, dramatically reduces the reliance on expensive, time-consuming real-world data collection by creating vast, usable data sets in simulation.
Right, solving the data bottleneck. So, on the societal impact side, or particularly regarding the workforce, what does this mean for jobs? Are we looking at a future where manual labor just disappears?
That's the million-dollar question, isn't it? The potential for job shifts is a major consideration, obviously. We'll likely see a transition. Some manual labor tasks, especially those that are dangerous, repetitive, or ergonomically challenging, will probably be automated. But this likely creates new roles in robot maintenance, oversight, programming, deployment, maybe even robot fleet management. Optimistically, you could frame it as jobs becoming safer and perhaps more interesting, with people focusing on supervision, problem solving, and higher-level tasks rather than the sheer physical effort.
But there's a transition period there.
Absolutely. And it's crucial to acknowledge the need for significant upskilling and retraining programs. Entirely new job categories might emerge, like human-robot team coordinators or maybe even robot ethics officers. This transition will require really careful management from businesses and governments.
Beyond jobs, what other major societal points come up?
Well, there are critical ethical and regulatory discussions that are already happening and need to accelerate. Safety standards are paramount, especially for robots operating closely with humans outside of fenced-off factory areas. Existing guidelines, like those from OSHA for industrial robots, are being looked at, but humanoids moving in general spaces present new challenges. And then there are questions around liability. What happens if a humanoid malfunctions and causes damage or injury? Who is responsible?
And privacy, I imagine, especially for robots in homes or, public spaces.
Huge privacy concerns, yes. For robots operating potentially in private spaces like homes, or even collecting data in workplaces or public areas, we'll need robust data handling protocols, clear user consent mechanisms, and strong security.
And finally, is there a geopolitical angle to this?
Definitely. We cannot overlook the global strategic race. There's a clear competitive landscape emerging, particularly between the U.S. and China. Both nations view leadership in humanoid robotics as a matter of national technological pride, economic advantage, and potentially a key driver for retooling global supply chains. Investment is pouring in from both government and private sources, both countries, and both have numerous well-funded startups and established tech giants pushing humanoid initiatives very hard. This suggests a future where the advanced components think sophisticated servo motors, sensors like that e-skin, powerful AI chips will be in incredibly high demand, becoming crucial economic and, frankly, geopolitical assets.
A lot to think about there. We love hearing your thoughts on all this. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about this rise of the machines. Is it exciting? Concerning? A bit of both.
So, to kind of wrap up our deep dive into the rise of the machines today, it seems clear that this isn't some far-off futuristic fantasy anymore. It feels like a palpable, ongoing revolution. Just the past week or so has been marked by really astonishing leaps in AI, innovative engineering like the E-skin, and significant investment heating up across the board.
That's right. Humanoids are swiftly transitioning from concepts, from lab curiosities, into actual working realities. And the emphasis, as we've discussed, has decisively shifted from just achieving basic mobility to demonstrating tangible utility in diverse, economically valuable workflows. It's about what they can do now. And maybe the provocative thought for you, our listeners, to ponder. The promise of these machines is pretty clear: enhanced productivity, maybe greater safety in dangerous jobs, more convenience across industries, and maybe even eventually in our homes. But the ultimate challenge, it seems, lies in ensuring these incredibly powerful machines are integrated into society in a way that's beneficial, that's human-centric. Will we soon see walking, talking robot colleagues and helpers as just an everyday sight? It certainly seems like the answer to that question is coming much, much faster than perhaps any of us ever imagined.